So today's topic is going to be using a chart to solve this problem. So we're given an equation here, and then it's always an empty container. And we add 1.5 moles, and it's a 1 liter container, so we have a 1.5 molar initial concentration of C. And then at equilibrium, we find that we have 0.3 moles of B. Okay, so if it's empty and we put in C, initially there's no A, there's no B, and so let's make a little chart, and it's just a graphic organizer to help us keep track of what's going on. Now, like I said, you can call it whatever you want. I grew up calling these ice charts. I call it a nice chart now, it's a nice idea. It's helpful. So I need 3 columns here because I want one for A, and I'm just going to put A2, B, and then C. All right. So and then N.I.C.E. Of course, I'm only using I, C, and E. So my thought process here is that I'm going to start filling out this awesome chart, okay? And I know that A and B weren't present initially, so that's going to be zeros. And I know that I had 1.5 molar concentration of C at the beginning, okay? So the other piece of information that I know is that B here at the equilibrium is 0.30 molar, okay? And so, looking at that, I can just cleaning up my chart a little bit here. I can figure out a lot of things, okay? First of all, I know that A and B are going to be equal because they have the same coefficient. Don't get confused that there is, that A is diatomic. That doesn't pay the bills. Okay, it's just the coefficient. So they have the same coefficient. So I know that A is going to be 0.30 molar. Okay, so that's the first thing I can fill in, is that I know that A and B are going to be the same. And then the other thing, since B has like a 1 coefficient and A has a 1 coefficient, and we know that they are gaining, we're getting more, we'll just say that their change is plus X. I think you see where this is going. The C, even though we knew how much we had initially, it goes down, the concentration goes down, so it's going to be a minus, but it's going to be a minus 2X. Because we needed 2C to make the A and the B. So minus 2X. And then we just have to solve for X. Now obviously 0 plus X is 0.3, so X would have to be 0.3. And so here 2 times X would be 2 times 0.30. And so that's going to be 0.60. So 1.5 minus 0.6. I think it's 0.9, but I'm going to check. I got it. So at the equilibrium, we are now pretty secure that we've got this much A, this much B, and that much C. So all we really need to do is we can figure out what the KEQ is now by just setting up these simple products. C squared over reactants, A2 times B, and it's a K because we are at equilibrium right there. and then you just plug in and go on your merry way. 0.90. Now notice I don't put the m after it when I plug in the equation because those brackets are what's telling me that it is. Whoops. You do need to write the numbers instead of b. Those brackets are what's telling me that it's molarity at that point. 0.9, and then that 0.9 is squared. You just saw me put that in there. And so that's going to be divided by 0.3 divided by 0.3, and I get a nice answer of 9. So pretty simple, not a big deal. That's all I got.